One example on this voltage divider biasing circuit. In voltage divided biasing circuit, so the approximate method as well as extract method we have studied. So on that we will do one problem so that we can finalize this. So now determine the DC bias voltage VCE and current IC for the voltage divider configuration of the network below. So take beta is equal to 140 and R1 is 39 kilo ohm, R2 is 3.9 kilo ohm as well as RC is 10 kilo ohm and RE is 1.2 kilo ohm. So the given same problem we can do even on MOSFET also. So that is using a transistor and voltage divider biasing. This problem is very important for the examination point of view. So you can see here R1, R2, RC, RE are the biasing resistance for the corresponding emitter base as well as collector. So take the problems notation what they have given. So we know that from the circuit RTH is equal to R1 parallel with R2 is equal to 39K, 3.9K as well as 39K plus 3.9K is equal to 3. You will get the answer as 3.55 kilo ohm. So ETH is equal to 2 volts and IB is 6.05 volts and IC we know that beta times IB. So what you have to know from this, RTH is R1 parallel with R2, ETH is equal to R2 VCC by R1 plus R2, IB is and applying KVL for that, ETH minus of VBE by RTH plus beta plus 1 into RE. So similarly, by the equation, so do it slowly. So RTH is equal to R1 parallel with R2, 39K. So that is VC is equal to VCC minus of IC, RC plus RE. So 10K plus 1.5K and 12.22 volts. So whatever the problem, if it is given, so read the problem twice and collect the data first. So IP is this. So same problem if you do for the considering approximate analysis method is also one same thing you will get the values. So VB is VR2 is equal to R2 VCC by R1 plus R2 and level VE can be calculated as well. VB is equal to VB minus of VE and VE is equal to VB minus of VBE and the emitter current can be determined. IE is VE by RE and ICQ approximately equal to IE. So how to find out the base voltage, that is base voltage can be determined with respect to this equivalent circuit you check out. So what happens and you have to find out the voltage across this. So apply potential divider rule. So output voltage VC to that resistance divided by sum of the resistance. So VCC to that resistance is VCC into R2 divided by R1 plus R2. So once if you got the VB, so you can say that is and VBE is VB minus a VE. Can I write like this? So VBE is nothing but the base emitter junction which will be equal to VB minus of VE. VE is equal to VB minus of VB and the entire current can be determined IE is equal to VE by RE and ICQ is approximately equal to IE. Can I write like this? That is IE is equal to VE by RE and ICE is approximately equal to IE. The emitter current can be determined by this. So how we can find out? That is the current emitter current which will be here. So emitter current which will be a voltage across the shunt resistance, if you know, so you can easily find out the current, or an ICPO is approximately equal to IE. So conduction that will define approximate approach. Beta RE is greater than or equal to 10 R2, where RI is beta plus 1 into RE equals to beta times RE. Can I write like this? Got this? Can do that. ICQ as well as C are certainly close. So exact analysis and approximate analysis, you can see that ICQ is milliamps is 0.85 and VCEQV is 12.22 and approximate analysis 0.867 and 12.03. It is clear. So this type of problems will be given to find out the variations in the given thing. So now we can see how the transistor acts as a switch. I'll summarize this once again. Biased stability of the system is measured of the sensitivity of the network or the varies beta, VBA, and ICPO to S dash and S double dash. So small changing and ICPO, small change in collector with respect to ICPO. So that is keeping beta constant or delta BBU by delta ICO or delta so this is how we can represent a biasing stability of a transistor. So these are the effective of non-effective circuit systems. You can see room temperature will be like this for 100 degrees centigrade temperature. It will be varying. The Q point which is shifted at the active region it will be represented in this, but in the Q point it is going to as saturation region. So this which will not be used at room temperature we can be used with the given frequency. So we are using the Q point should be a certain part of the output will be clipped off or a chopped off. So we will the stability of the transistor is required. So we can see here it works in S dash as the S double dash. S dash is the IC divided by ICB, keeping beta constant. IC by delta will be keeping an ICBO constant, and delta double S delta IC by delta will delta be keeping VC constant. So similarly, you can find out an ICBO for an emitter configuration. When ICO is equal to beta plus 1 plus RB by RE, beta plus 1 and RB by RE. If RB by RE is greater than beta plus 1, it will be reduced to S naught is equal to beta plus 1. And for the RB by RE, beta plus 1 stability, and ICBO is RB by RE. So this is the stability factor of a transistor. So it will be varied with respect to frequency. So next as you can do the problems on this. It is clear. So to find out VTH and RTH, so R2 VCC by RL plus R2, step 2. So the one more step which has to be known, that is for the exact analysis. So what happens, the is equivalent network. So apply KVL to this loop, input, so the drop across this, and drop across the junction, and the drop across the RV will be equal to 0. The voltage across this, and voltage across this, and also the voltage across this. So from this equation we can find out IB. IB is VTH minus half VBE by RTH plus beta plus 1 into RE. So VBE by RTH plus beta plus 1 into RE. VTH is another VBE by RTH plus beta plus 1 into RE gives the answer. This So this is regarding with the transistor biasing, that is an voltage divided bias with the problem.